Hey everyone, it looks like we're live here. Welcome. Glad everybody was able to make it. A couple things I wanted to touch on. This is, I think, the fifth one of these, or fifth or sixth one of these that we've done so far. Some really good stuff from the past. Just on Monday, Mike Sandy did a really cool desk design using some of the weldment functionality, stuff like that. Mike Spocek last Friday did some really cool stuff with for his hot rod, making some custom parts. So I thought that was really good. By the way, good luck on Monday, Mike. Um, so what we're going to do today is we're going to kind of focus on some of the tips and tricks that I've learned over the years with Model Mania and just some productivity tools to kind of get everybody up to speed. So what is Model Mania? Actually, first I'll introduce myself. My name is Mark Schneider. I work at SolidWorks. Been at SolidWorks since '96. So I've been around for a while. Um, what we're going to do, just to introduce what Model Mania is, it's a modeling contest that we hold at SolidWorks World, or not SolidWorks World, 3D Experience World, previously known as SolidWorks World. So we've done this since the year 2000. So this is our 21st year doing this. Been doing quite a bit of them. It's been a lot of fun. It's a friendly contest where you sit down, you model a part, you make a change to that part, and then you run a quick simulation. So one of the things that I learned over the years from doing Model Mania, running this contest for this long, is some tips and tricks that really help with productivity, help other people. And the other thing is, as I grade all the parts, I get to see how different people approach it. So there's so many different approaches that are you know all valid approaches. Some are a little bit faster than others. Some are work a little bit better, but for the most part, they all work. So I'm going to run through various scenarios of how you can build these parts, and there are videos online, and I'll show at the end where you can get more information about Monomania if you're interested. So all that information is available, but one of the things, those videos that are there are kind of a quick run through, one way to do it. One of the things I want to do today is actually go through in a slower fashion and try to understand how that works, and then provide some kind of tips and tricks so that people can learn from it. So let's go ahead and get started. So this is this past year. So at 3D Experience World this year, we held yet another, our 21st Model Mania. This was the part that was given to the contestants. So the contestants don't get to see this part ahead of time. They sit down and they have to model this part. They get 20 minutes to do it, so it's a timed contest. So once you sit down, you study this part. You figure out, okay, how am I going to approach it? And what we do is we actually give you these hard copy drawings like this. We give you some of these hard copy drawings so that you have that in front of you. One of the other things we give you is these little rapid prototypes. Helps you understand the model, helps you get a good feel for what it is. The guys at Rise printed these for me this year, so thanks to those folks over at Rise 3D. So let's go ahead and get started, figure out how we're going to approach this. So if we look at this part, you can see it's kind of got three arms on here. So symmetry is going to be a good thing as we go. If we look at some of the dimensions, 16 and 20 defines this central boss here. Okay, that's pretty straightforward. We have this arm that comes out that's centered about the horizontal axis there. That's 22 degrees. And then we have a radius out here of 6, bolt circle of 70. So let's go ahead and get started. We'll refer back and forth to our drawing as we go. The other thing, actually, before we do that, notice this face down here, this 112 degrees, and this face that comes across here. You can see that's a continuous face. So that face is actually conical. So we're going to need to think about how we're going to approach that and how we're going to do that. So let's go ahead and get started. So let's start with just a blank sheet here. And what I'm going to do is start on the top plane and just draw a couple circles in here. So this one's going to be 22 and 16. And then what we're going to do is just extrude that. So features, extrude, kind of the basic stuff. I'm going to go through and do some things that you might not be used to seeing as you go through. Hopefully I can, I'll take it fairly slow, but I'm also going to go pretty quick because the point of this contest is to go pretty quick. So we're going to start drawing in that arm. So I'm going to, on the top plane, I'm going to create a sketch. And one of the things you'll notice that I like to use as I go is the mouse gestures tool. So you'll see this pop up as I go. Sometimes it goes by so fast you won't even notice it. So be aware that you'll see that. I'll show you how to set that up. The other thing that I'm going to use is the shortcut toolbar. So this shortcut toolbar is done by hitting the S key. You hit the S key, this toolbar pops up. It's fully customizable for parts, assemblies, drawings, and sketch. How do we customize these things? So here's your mouse gestures. You can set this up to have 8 gestures, 12 gestures, 2, 4, however you like to do it. But again, there's certain areas like in Sketch, I use a lot of the mouse gestures. Obviously in assembly, I'm not using it because some of these are just blank and they're not been filled out. So I'm not using it as much there. I do use it a lot in drawings as well. So that being said, that's how you set it up. You come over here, you find the command that you want, whatever, you can do some whatever, just drag it onto there, and then that one is actually there. You drag them away. That's how you set those up. The other thing is the shortcut toolbar. So here you come over here to your shortcut bars, and these are all fully customizable. So again, you have all your commands that are available to you no matter where you're at. You can drag those onto your shortcut bar. So please use these tools because these can really help you with productivity for commonly used commands. So that's kind of cool. So you'll see these things as I go. So let's jump to a top view here. And I'm going to draw in the center line. So I like to use center lines because they're visual for me. They help me understand, that relationship. So I'm going to type in 35 because our bolt circle was 70. Half of that is 35. I'll draw a circle in here. This one is going to be 12 because the radius for that was 6. It's not necessary, but you can change that to display that as a radius if you want, because that makes you just that visual of being able to see it on the drawing as 6 and then see it on your model as 6 might help you. We're going to put that angled arm in there. So I'm just going to draw a line out here. It's picking up tangency as I go. I'm not sure how far to draw this here, so I'm just going to draw it to say there. Add actually, let's just crossing window, selecting, and I'm going to choose mirror entities. Now you may not see this mirror entities on your context toolbar. Again, this is fully customizable tool too. This is when I choose in the graphics area in a sketch, I have the convert entities and mirror entities because I use those commands all the time, and that just pops up, makes it right at my fingertips. So we'll mirror that to the other side. All those commands are available up here. You can put them on your mouse gestures, put them on your shortcut toolbar, whatever you want. But again, everybody works a little differently. Add a dimension between here, and that's going to be 22. And then we don't pick up that tangency there. If I refer back to my drawing here, you see it's not really tangent with my cylindrical boss there. So I'm going to need to terminate that somehow. So I'm just going to draw a line from here down to here. Oops, sloppy sketching there. Hook that up. This I want to be vertical, and I want it to be at the midpoint of that, the midpoint of the line onto the origin. So we'll go ahead and make that midpoint relationship. So my sketch is fully defined. It's black. It means it's fully defined. Now I'm going to need to extrude this up. But how high do I go? If we refer back to our drawing, we don't really know. There's no dimension. We have a 6 here. So it tells us 6 and then this 112. So what we need to do is we need to define that conical face. A couple ways you can approach this. If you watch the video I did, I actually used a surface to do this, but I'll do it a different way here. I'm just going to go ahead and take this sketch here, again using the shortcut toolbar, add a boss, and you notice I didn't clean up my contours here. I'm just going to grab this and this. Notice what's going on back here. That's not what I want. I don't want to add material there. So I'm going to exit out of there. I'm going to grab this edge and I'm going to convert that into sketch geometry. So now I have that information there as sketch geometry. We'll go ahead and do an extrude here. Grab this, this, and this. And how high do I go? Well, I'm not quite sure. I'm just going to bring it up to there because that's probably close enough. Actually, let's do this. Let's do it the hard way. Make that 22. So I bring that up and that face obviously merges because I really didn't know how tall to make that guy right there. So how am I going to cut that away? Well, I'm just going to do that with a revolve cut. So on the front plane here, I'll create a sketch and I'm going to grab this edge here, and I'm going to convert that into sketch geometry. I'm going to draw a line over here to, I don't know where. We'll just draw down and we'll come down here. Grab this line here. So one thing about when you convert an entity, I'll grab this edge here and I'll say, I'll convert that. So everything looks black right here, right? So that's converted. It has an on-edge relationship, but these endpoints are still manipulatable, if that's a word. So you can still drag those endpoints around. And you still maintain your on-edge relationship. So that's kind of an interesting way to do things. So this edge here, I'm just going to drag it up there. We'll add that 6 millimeter dimension there. We'll add our 22 angle. And then I need to define how far in and out this goes. Well, I really want to build intelligence into my design, and I want to make it tied to that same cylindrical face that existed there before. So what I'm going to do is I'm going to turn this sketch on here. And here's that edge that I want to use. And in order for me to align this with that, I'm going to use the Pierce relationship. Toby talked about this a little bit earlier as one of his favorite tips or techniques. I also agree with him. I'm going to grab that point and I'm going to grab this line or this circle. So when you think about Pierce relationship, think about a plane and think about a pencil or something going through that plane. So where that pencil pierces, where that line, this is my circle, where that line or whatever pierces your plane, that's where your Pierce relationship is. So I'm building a Pierce relationship where this circle pierces my sketch plane, if that makes sense, hopefully. So we'll add that Pierce relationship, and that locks it down. The good thing about this is now I've built in design intent into my model. So if the diameter of this changes, so will my cut. So everything's up to date. I'm going to need to revolve that about an axis, so we'll just draw in a vertical center line here, pre-select that, and that allows me to use that as my revolved axis. So that line goes in there when you pre-select it while you're in the sketch. We're going to go ahead and cut revolve 360. So that looks pretty good. Let's go back to our drawing. Any questions so far? Let's see. I'm not sure if I'll be able to monitor the questions very well through the chat here, but I'll do my best. How do you choose offset dimensions for part drawings like in this picture? I'm not sure which picture. I'm about 30 seconds delayed from when things take place, so I'm not sure I get that question, but shout out to everybody that's on here. I'm coming to you from Cincinnati, Ohio. Weather here is cold and rainy. Good day to be inside doing some part modeling. So happy to have everybody here. So let's come back to our drawing. So we got kind of the rough shape in. We kind of know what we want to do there. So the next thing we want to do is put these counterbore holes in here. So we have 3 counterbore holes. It's identified as 4 millimeters from the bottom as its depth, and it's a counterbore for an M4 socket cap screw. So I like to use the hole wizard for that, but I got to think about how we're going to define where that hole goes there. A couple ways we can do this. Let's come back into our model. I could come back here and put that hole right here. That's one way to do it. That's probably the best way to do it. Let's go ahead and do it that way. So I'll use the hole wizard. I'm going to do it. I'm going to do it the wrong way. Show you how that works. So I'm going to come down here and say I want to put that hole in. Maybe I don't have that. Maybe I did it different. I didn't have that face up there. So I'm going to use the hole wizard. We'll do counterbore hole. These are all of our standards that are available. I'm going to do a socket head cap screw, M4, and I got normal fit, everything. If I look at the custom sizing, you can see that the depth of from the top face to the head is 4, but I want dimension from the bottom up to be 4 millimeters. So I'm not going to do any custom sizing here. I'm just going to go ahead and place that in there. So I'm going to go into my positioning for this hole, and I'm going to say I want to place this hole right on this face. Well, it's coming in normal to that face. That's not what I want. So I'm going to take this, let's just add another point. I'm going to add another point up here. And you can see now it's coming in normal to the top plane, but it's not in the right position. I can move this out here. Notice that that has an on-plane relationship. That relationship is tied to that top plane. So it's on that plane. Here's our sketch point here, and I'm going to make those coincident. No, I can't do coincident because I'm in 3D Sketch. I'm going to make that a long Y. along Y. So that means those two are along the same Y direction there. So I've positioned that in there, but you can see that's not really what I want, but that's okay because we have another trick I can show you here. So I'm going to come into this sketch here. So these are the sketches that define that whole wizard hole. So I'm just going to right click, edit this sketch. Don't know why it flips me upside down like that, but let's just switch over this way. And this 4 millimeter dimension here that defines the location for the planar face for the counterbore hole, I want that to be dimensioned from down here, and I'm going to change that to 4. The nice thing about this, doing it this way, you can see I got my nice hole in there. We'll hide this sketch here. The nice thing about doing it this way is if your model changes, let's say this thing gets taller, you're still going to maintain that dimension. I could have done some math and said, okay, the height of this was 22, and I went 4 from the bottom, so that's 18. I could have redefined the depth of the counterbore to be 18, but then my design intent wouldn't be captured. So I like doing it this way. Remember, these sketches are editable. You can come in and edit it, move the dimensions around if you want, so that's kind of nice. All right, so we have this part of it done. Let's, how are we doing on time here? We're doing great. So let's pattern this. So come back to our drawing here, see what we got. We have 3 of these. We got our counterbore hole in. We don't have our fillets on. I always say fillet late, fillet last, or fillet late, draft early, fillet late. These 22 millimeter millimeter radii, I can't get in there until later. So let's go ahead and do our patterning, and we'll put our 22s in and then those on, and I think we're kind of good to go here. So we'll pattern this thing. I'm going to do a circular pattern. Direction is going to be around here. My features, I want that top cut. I want that feature there in my counterbore hole. We'll go ahead and accept that. So far, so good. Let's add a fillet. I'm going to grab this edge here. My selection helper pops up. I can walk through here and see what I want. That's the one I want right there. These are going to be 22. Make those 22 millimeters. No problem. All right, let's add another fillet here. This is going to be 1, and we're also going to, what I do here, I'm in the fillet expert. Let me cancel that. Let's go to manual filleting. Just a regular manual fillet 1. I'm going to choose this edge here. I don't need to see that there, so I'm going to choose this edge here, and we'll make those 1. So those are fine. This isn't necessary, but one of the things I sometimes like to do is I like to change the color of those fillets. It's very visual, helps me understand, helps me visually see that, hey, I got all my fillets on there. So that looks like it. The last thing we need to do is apply the material, and that's plain carbon steel. So there's our part for phase 1 for Monomania. See, make sure we got everything. We got our fillets here. We got our counterbores. We got diameters there, 120. That's fine because we're equal spaced around 360, 22, 6. Yeah, we're all good. So we got everything, and there's our material called out. See how we're doing on our questions. I know I got some guys helping me with questions here. Including do threaded included in hole wizard. Yeah, we have all the threaded holes are in there. Hey, Eric Beatty, how are you? How's things at Omax? Good to see it. He answered that question for me, including pipe threads. Yes, including pipe threads. Thank you for that. All right, so now what happens is you're done with this, and we say, okay, now you got to make some changes to this part. So that's phase 2 of the Monomania competition here. So here in phase 2, we got to do all the changes that are indicated in the red revision clouds. So what do we got here? Let's zoom in here. We have 3 by 3, so that's these 3 by 3, so that's on all 3 of the arms. So we got an offset here, an offset here. That line is still straight there. We have a 3 millimeter offset here, 3 millimeter offset here. The distance over here is actually 22 minus 16 divided by 2 gives me 3. So that's a good opportunity to use the shell command. You can do offsets, use the sketch in offset. A lot of people did that too. But when I see all these offsets like this, sometimes I think shells would be a good opportunity there. So we have that. This fillet changes now to 30. Okay, that doesn't seem too bad. And then this angle changes to 8. So remember when we sketched that out before, it was wider, and came in here. So that's going to go down to 8. Let's do the 8 degrees of 8-degree change here, and then we'll also do the offset there. So I'm going to come back to my part, and we'll do our 8. Let's see. Make that 8. Oh, so one thing I want to point out here, I'm using Instant 3D. I personally prefer to use this. It allows me a single click on a dimension to quickly change that. You can choose to use it or not. I also use the Instant 2D, so I have very similar capability inside of the 2D environment. The other thing that it gives you is it gives you the ability to grab these little drag handles and move things around. So you kind of get some real-time interaction. So that's some of the things that I use with Instant 3D. I have it turned on nearly all the time. We're going to change that to 8. So that was pretty easy. Our fillet here, that's our 22 millimeter fillet. Okay, we're probably going to have some challenges there because how am I going to put a 22 mil or a 30? It's going to 30 across those faces there. We'll have to do that. And obviously, this no longer runs around, so we can repair that. Let's roll back before these fillets here, and let's get that pocket that we put in there. So I'm going to do that using the shell command, and that was a 3 millimeter shell. You can show the preview. Yep, that looks like it's right. Go ahead and accept that. So that shell takes care of all those faces for me, including the bottom. So if I were to cut a cross section here, very similar to what's on the drawing, you would see that, oops, I don't want to, let's do it this way. Move this guy out a little bit. There we go. You can see that I have my pocket in there and I have my 3 degrees of draft all the way, or 3 millimeters of shell all the way around. So that goes pretty good there. All right, the next thing we got to get that these dimensions on. We did our 3s, we did our 3, 3, 3, we did all that stuff, and then we did our 8. So now we got to get this 30 in here. How are we going to do that? So this face, let's just do it this way. I'm gonna do it kind of the hard way here. I'll sketch on the top plane up here. And let's just grab this edge and this edge. And I have one of the other things that I have, and I use a lot, is convert entities. So I have that set up on hotkey. So I'm just going to hit my hotkey, and that's going to convert that. Again, as I said before, you can tweak these and move these back. We'll do a tangent arc between here and here. And I want that point there to be tangent as well. And we'll put that 30 millimeter dimension on there. So I could do this, we'll convert that entity there. So I could do this and kind of extrude it up, but how I'm going to extrude it up to where? So I could extrude it up a little bit past and then use this sketch here and come back and clean it all off again. That's one way to do it. And then I'm going to have to do that 3 times, or hopefully I can make that work in a pattern. Can be very, very difficult, very challenging. I'm actually going to exit out of this sketch and show you another way to do this, which is actually pretty cool. So what I'm going to do is I'm going to use the fillet command, and I'm going to use a face fillet. So a face fillet allows me to add a fillet between 2 faces, and irregardless of whether or not those 2 faces kind of intersect with each other. So I'm going to grab this face, right click this face, and I'll right click. I'll say OK. Oh no, I got to change that to 30. 30. So what the face fillet does is it puts a fillet between those 2 faces, and the way I like to think of it, it absorbs any faces that are inside of there. So that face will actually be what I call absorbed or swallowed by this particular feature here. So I'll go ahead and accept that. You can see what that did. I still have a single continuous face that comes all the way around, so that's kind of nice. The only thing is we got to do this a couple more times, so we're going to choose here. One of the things to watch when I click this face, watch what happens on my mouse. You'll see a little, on my right button, I get a little down and over, like an enter key, so I can right click, right click, and it goes very quick. Hit the enter key to bring up the previously used command, click, right click, right click, and those go on quite easily. So that is probably the easiest way to do it. When you get into that situation where, hey, I need to kind of remove a face or swallow a face, think face fillet. This is our 22. I'm just going to delete that. We don't need that anymore. And then this guy here is my fillets that go all the way around. So Let's edit that. You can see I have a missing edge, which is that one up there. So I'm just going to clear all missing references here. That outside edge, okay, I'm still going to need to fillet that. Now, all these inside edges here, inside faces here, these need to be filleted. So I could start selecting faces, kind of doing it this way. But an easier way to do this is to try to fillet a feature. So I'm going to try to fillet my shell. You can see what happens. It fillets all the edges that are associated with that shell feature. Single pick, I got both of these in there, and it's going to fillet all the edges associated with that feature. So I'm done with that. If I look back at my drawing here, one of the things you'll notice is that there is not a fillet on the top, actually up here. There is not a fillet at the top there, so I'm going to need to get rid of that fillet. How do we get rid of that fillet? I'm going to show you two ways. I'll show you the hard way first, and then I'll show you the easy way. So the hard way would be, I could go back in and reselect and start selecting all the additional edges. Another way to do it is to use the Fillet Expert. Fillet Expert is really cool. You don't pre-select the fillet to make a change to, if you will. What you do is just choose the fillet command, go into Fillet Expert. You have this button, this tab here that allows you to make a change. So what I want to do is I want to change this fillet. I could change it to 5 and hit resize, and it'll change. What I do, I did something wrong there. Oh, I made it too big. Let's undo that. So I could change it to 0.5, resize. Oops, I didn't choose it. Choose this guy, and we'll say resize. So I can actually change that one fillet to resize it. Or I can choose this fillet here and then say remove. What that does is it removes it. So that's pretty cool, but if I go ahead and accept that, then I have my part as I want it. The only problem with that is that what it does to your model is now, remember we chose a feature to fillet. So now I have all these edges, and if anything changed in my geometry, I'm something that moves something around, some of these edges might change, some of the faces might change. So you got to watch out for that one. So let's just undo. Back to that edit feature here. Okay, we got to put our fillet back in. So we'll put our fillet back in. I'm just gonna clear everything and choose this edge, and we'll choose our shell feature. Everything goes again. So that was one way with the Fillet Expert. A great way to go and just change one fillet or remove one fillet. But the easiest way to do it is use the delete face command. So I'm just going to choose delete face, and I'm going to make sure delete and patch is turned on. So just delete and patch and hit OK, and that'll delete that. It'll heal those two adjacent faces up to each other. So quick and easy way to get what you want. And the nice thing about it is if this shell ever changed, it's still going to try to fillet that shell. So how we doing on time? We're not doing as good as I wanted. Okay, so that's the modeling of the part. So then we ask you to do a simulation. So if we come over to our drawing, we'll do a quick simulation here. So we're saying apply 2,000 Newton load onto the green face. We have a load direction here, so that's going to go up. And then we're going to fix all these blue faces right here. All right, so let's go ahead and do our simulation here. It's going to go pretty quick. I'll just use the Simulation Express. Everybody that has SolidWorks has Simulation Express. I personally like to use SolidWorks Simulation, but for this example, we'll use Simulation Express. So we'll come in here, and I'm just going to say next. It takes me right, kind of walks me through a wizard kind of methodology for interacting with my model. Add my fixtures, tells me what to do. I want to add a fixture to this face, and this face. Go ahead and accept that. And then we're going to go next, and we're going to add our loads. So we're add a force to this face. I don't want it to be a normal. I want it a normal load. I want it to choose a direction. And in Simulation Express, you have to choose one of your planes to define your direction. And this is going to be what, 2,000 newtons. Make sure my direction is correct. It is, and we'll go with that. So I have everything set up properly, and I'll turn off my simulation little indicators that are on the screen, and then we're going to run it. So I'll go through the wizard here, and I'll hit next. Material was already defined because we defined that earlier. Hit next, and then just run. So we'll hit run. We'll go off and run our simulation, come back with with some great animations here. So first thing it does is it says here, this is what we did. Does the part deform as you'd expect it? Yeah, that's what I'd expect. So then I can hit yes. Here you can get all kinds of information. If I want to see the von Mises stress, I can see von Mises stress here. If I want to show the displacement, I can do that there, or the factor of safety. In this case, our factor of safety. That's what we asked you to put in. What is the factor of safety of the part? Show factor of safety anything below, say 10, and you can see those are all the areas below 10. So it kind of shows you your areas that basically would be below 10. And in this case here, a factor of safety 3 is probably good for that part. So that's Monomania 2020. That's what we did this year. You know, went through it in a maybe a little bit slower fashion to try to give you some idea. So let me see how our questions are doing. Sketch pictures, it looks like Peterson's taking care of a lot of those questions. Thank you, Mark. Thank you for that. And like I said, I'm probably behind on my color of features. Simply select the feature. Mark already answered that. So thank you for that, all that work, Mark. You're taking care of me here, brother. All right, so that's done. We're done with that one. Let's do another one. Let's do 2019, and we'll do it again in that kind of slow fashion and walk you through. So we don't need to save any of this. We'll close the empty part down. And we'll do 2019. This one was inspired by my colleague Michael Steve. So when I come up with these parts, um, I have some inspiration, something that I see, and I start modeling. I try to figure out how can I do this in such a fashion where the contestants can sit down and actually get this done in a reasonable amount of time. 20-minute timed contest to do phase 1, phase 2, and the simulation. Um, so this is the part. It looks pretty simple. Here's our part right here. Got our little rapid prototype, so you can, Xometry folks at Xometry printed these things out for me, so that was kind of nice. But you can see, it looks pretty simple. I got this part that's 70 by 24. If I look at this cross section over here, I have a reference dimension of 30, 22 for the center of that 10 millimeter hole, and then this radius is 8 out here. I don't have an angle on there because it looks like everything's defined by 8 and 22, and then this width here of 24. So let's go ahead and get started with just that right there. I got some interesting things in phase 2 of this one, just different methods and techniques that you can use to get the job done, if you will. So we have that. We have this 5 degrees of draft on both sides. That looks pretty easy, pretty straightforward. And then this counterbore hole for a M6 button head cap screw. That's centered around there. So everything looks pretty good. 2 millimeter fillets on this model. So let's go ahead and get started. Let's start another new part. I'm going to do this on the right plane and draw a line. So one of the things I'm going to do is I'm going to choose the midpoint line. Don't use it often, but when I do use it, it's handy. So that takes me to, I just keyed in 12 from midpoint to the end, and that doubles it for me and puts 24 on there. This dimension here, or this line here, it continues into the line command. So I'm just going to come out here, move my mouse back to the origin, and I transition into an arc. And then we'll come over here and notice I'm picking up tangency as I sketch, and I'm just going to drop that right there. Now, I mentioned before I like to use construction geometry to kind of define things. It helps me visually see that, hey, I have a horizontal line there and that those two are aligned. So we said this dimension was 22. That looks good. We had a radius of 8. My sketch is fully defined at this point, so that looks good. We had a hole in there that was 10. Let's go ahead and put that in there. And that's a pretty good start at, the shape that we want to make. So let's just take that one and double click to get out of my sketch. I'm just going to grab this sketch right here and tug it out. And it was 70, so I'm just going to go 35. So half of 70 gets me there. That looks pretty cool right there. Now we needed to, if I will come back to our drawing, I'll show you what we're going to do next. So we have this 15 millimeter circular cutout that comes from the same or the same location of the other holes there. So let's do that 15 there. I'm going to do that on, let's say, our right plane. We'll go ahead and create a sketch. I'll draw in a circle. Oops, circle. Wake that up, and we'll say that's going to be 30. And if you want, like I did earlier, you can change this to be a radius dimension. So that shows up as you would expect it. So I have this circle here, and I'm going to extrude and cut that material away. So let's do this using Instant 3D here. So I'm just going to, I'll do it wrong. I'm going to grab it up here, and I'm going to drag this over here. See what happens? It added material, but I have this option here where I can add draft, or I can actually turn it into a cut. That's one way to do it. I'm going to delete that, and I'm doing another way. If I choose my circle here instead of here, so here it's actually it's on the face. It's actually on this particular face. If I grab it here and drag it, it knows that you want to create a cut. Okay, undo that. If I grab up here, it thinks I want to add material. It doesn't know I want to add a cut. Undo that. So kind of quick and easy thing to remember. Save you a step or two here and there. We'll extrude that to be 25. That's kind of cool, the way Instant 3D works. We got to add that draft. So let's come back over here, and we're going to add our draft. And we want to choose regular neutral plane draft here. And this is going to be from our front plane. You ought to watch this little arrow here. Oops. You got to watch this little arrow here. That's your direction of pull for your neutral plane. I'm going to be pulling towards me. So we'll go ahead and do that. And I want to draft this face 5 degrees. So that drafts that face in. That looks about right. So let's go back to our drawing, see what we got. So we got our 5-degree draft, we got our 50 in there, 70. We still didn't put our hole in there, but that's okay. We'll get to that. All this stuff here is done with the exception of the fillet. So let's go ahead and put in this counterbore hole. Notice there's a reference dimension over here, 3.3. So that is from the tangent portion of the 15-degree radius cut there to the depth. So that we got to just make sure that that depth is proper, 3.3. Button head cap screw, M6 button head cap screw. So let's come back over here. Let's actually mirror our part over at this point. So I'm going to use the mirror command, choose this face. I can choose the individual features and try to mirror it over that way. Probably a better way to do this is to mirror the whole body. What that does is, hey, everything that was created before now in this body is going to mirror over. The great thing about that is if I came and added additional features to this part, they would mirror over too without me having to select those features in my mirror command. So that's kind of a nice capability there. So we'll do our whole wizard again. I said M6 counterbore for M6 button head cap screw. It's going to be an M6. And what I always like to do is take a look at my custom sizing. The depth is 3.3, so our depth is already correct, so we don't need to worry about that. Again, we'll go into our positions. It's going to be, since I'm creating this whole wizard hole on a non-planar face, it's going to automatically take me into the 3D sketch environment. So I'll just choose this face here, and it knows to do that. Notice what it's doing with my preview there. You can kind of see that it's staying normal to that face. So I'm just going to go ahead and place that right there. Place that right on that face. That's fine. Now, how am I going to position this? Let's actually look at it first. It has an on-surface relationship. That's important. Make sure that that's on that surface. How am I going to position this? I want to position it right down the center of my model. I could add dimensions like it was called out, but I know that this is right down the center of my model. So I'm going to grab this point. I'm going to grab my origin, and I want to say I want those to be along the same z-axis. I'll choose along Z, and that will make my sketch black and allow me to add that hole. If I wanted, I could come in here, measure the distance between those two faces. Sure enough, 3.3, so just double check in there. Now we'll add those fillets. Those fillets are, what size, 2? Those are 2s. So add our fillets. Just use the fillet tool here, key in 2. And I'm going to grab this face, I'm going to grab this face, but remember those fillets need to wrap all the way down around here. So I'm going to grab this edge and this edge. You can see that fillet's going to wrap around. You can add some color just for grins. And we'll make that, say, red. There we go. Add or apply our material, plain carbon steel. And there's our phase 1 of this one. So that was pretty easy, right? So sometimes it looks pretty easy in phase one. Let's see if we got everything. We did that. We did that. Yeah, we did all this stuff. Let's see if anybody caught me doing something wrong over here. Sketch picture. Always people talking about sketch pictures. We need to do a whole sketch picture hour. Weldment design. Sandy did a really cool weldment design using, or he designed his desk using the weldment tool on Monday, I think that was. It was a really cool application for the weldment stuff. Take a look at that one if you get a chance. All right, so I think we're okay on our questions. Let's come over here and take a look at what we need to do for phase two. So phase two, throw another drawing at you. Think of it as your boss dropping another drawing out and saying, hey, I need you to make changes to that part that you just knocked out in 10 minutes. Here, can you make these changes and run a simulation? So what you get is, well, let's take a look at what we got again. Make changes as indicated in red, revision clouds. So come in here. So obviously we have two counterbore holes and they're spaced here. If we think about it, those are centered. 20, 30, that leaves me 20 on the other side to give me 70. So that's still going to be centered. We added these 2x30, so these are arced now, 30, and still drafted and still maintained within that 70 overall width there. So we're going to have to take care of that. And up here, we have this inside draft of 8 degrees, but we want to maintain 50 millimeters between center of hole to center of hole. And I got 3 different ways I'm going to show you how to do that, all of them kind of fun. So let's take care of the other stuff first, and then we'll come back and do this. First of all, we'll take care of this 2x30. Let's come back to our model here. How are we going to do that? Well, we've got to go back before that draft, of course. We need to cut some material away. So I'm just going to sketch on this side, on this back face here, and put in a 3-point arc between here. We'll come down here, come here. I'm going to choose these 2 items here, make that tangent. I want to make sure that these 2 items here are vertical to each other. And you know, I said I like to use construction geometry. You could have put one of those in there and made that vertical as well. And then that's going to be 30. So I have an open cut. So that's, I'm going to create an open cut because I have an open sketch. It's not closed. I don't need to fully close that. So what we're going to do is just use the shortcut bar, bring up my cut extrude tool, and a couple things to notice here. So I want to cut this through all, of course, but see this extra little arrow in here? That's the flip side to cut. So it tells me which side do I want to cut. I can choose it on screen, or I can choose it on screen, or I can choose it over here. Doesn't matter. But what I want to do is I want to cut the material away to the outside. Makes sense, right? So we'll go ahead and cut that material away. That worked out good. We have that 30 millimeter arc on there. Now, what about our draft? Well, that face went away. That flat face went away. We could just cut it. So I'm going to change this. Got a missing face. I'm going to say draft this face now. It's going to automatically remove that missing face for me, so I don't need to go and clear that away. So let's take a look at what this looks like here. Oops, here we go. So there's our 5 degrees of draft that we just added on there, and we have our curved face there. So that looks pretty good there too. All right. Now let's do the counterbore holes. Let's get that out of the way, and then we'll come back and show you a couple different techniques for adding that draft to the side face there. Counterbore hole. So I'm just going to go straight in and edit this 3D sketch. So that's the position, the 3D sketch. So remember before we added a long Z relation there. Got to keep the on surface. I'm going to delete the on Z relation. So now I can take this and move it around on that surface. It stays on the surface. And what I want to do is I'm going to draw another point just on that surface as well. You can see that point has an on-surface relationship as well. And then I'm going to draw a construction line between those two. I want this construction line, since I want these to be aligned to each other, I want those to be in a long X relationship there. So we'll make that a long X. That's fine. Now, how am I going to position this? How am I going to dimension that? I could come back, say, here. Where's that one there? And show this sketch and try to find a midpoint there and dimension, from here to there. Gets a little difficult. Since that is centered, what I'm going to do is just kind of do it very easily. And this captures design intent as well. So I've drawn a line from that origin to the midpoint of this line. And I want this line here to be along Z. So that locks everything down except for the width. And that width is 30. My sketch goes fully black. Exit my sketch. I now have 2 holes. So that is pretty slick, easy way to do that. Working with 3D sketches is very powerful. It's not I won't say it's the easiest thing to work with, but a little practice and you can do some really cool things with 3D sketch. So I encourage you to play around with that. So what are we going to do? We got to do this draft stuff up here. All right, so we got 8 degrees of draft, but we want to maintain this 50 to the center hole to center hole. So what I'm going to do, not necessary, I'm just going to come back here. Let's go actually back before I mirrored. And on the top plane, I'm going to create a sketch. And this is only just for me playing around. Let's actually just do a construction line. I'll come from here, I'll come out, I'll make that vertical, I'll come over here. Now, I want this line to be, I want this line to basically be 25 millimeters and on that center line there. So an easy way to do that is to take this edge here and this point here and say, I want a midpoint relationship. You'll say, why did that work, Mark? How does that work? Well, the reason is if I took this line here and I converted it, it knows to convert that, which is basically that circle, which is in my plane, into a single line. It knows how to do that. So that's how I'm able to choose that midpoint and get that to work. So I really don't need that line on there. I have a fully constrained sketch. This is 25, so that's going to help me just understand whether or not I'm getting my draft right. So we'll exit that sketch. Again, that's not needed. We'll hide this one here. And the next thing we want to do is start playing around with draft. So that's maybe a good approach here would be, let's make it 8 and we put this as our parting line. We'll flip our direction. There's our direction right there. And we'll try 8. We'll draft this face. Obviously, that is not what we want. What about parting line draft? So let's edit our, I don't want to do that. I want to edit my draft feature. Edit my draft feature here, and I'm going to say, let's try parting line draft. What do you think? Think that one's going to work? Choose this edge. That's the direction I want to go. You got to make sure you watch those. Again, that's not exactly what I wanted either. So how am I going to approach that? What I want to do is actually, because of the way we've approached this, I want to actually add material at the bottom and remove material at the top. Let's go back and look at that real quick. So here where the draft is adding material, here it's removing material. So how are we going to do that? Well, the draft command is very powerful. So what I'm going to do is I'm going to hide our little sketch here. I don't really need it. And I'm going to turn on my temporary axes, and I'm going to grab this front plane here, and I'm just going to drag it out. Holding down Control key. I'm holding down Control key. I'm dragging that out. What that does is creates an offset plane. If I choose a second reference, and that reference being that axis there, it gives me a plane that's through that axis that's perpendicular. I want it to be parallel. So I'm defining another plane that's through that axis. Jump to a bottom view here. Through that axis, that's my axis there. Everything looks just as I want, and we're going to use that as our neutral plane for our draft. Actually, I move my draft down here. That's fine. Just do a reorder. Edit this feature here, and now I'm going to make a neutral plane. And my neutral plane will clear this guy. Get that out of there. My neutral plane is going to be this. Faces to draft. It's going to be this. I'm going to say go. Oh, did it wrong. Change my direction of pull. I didn't watch my little arrow here for direction of pull. 8 degrees of draft. And what that did then is it added that 8 degrees draft by removing material. Let's check it with this guy. Show this sketch here. Turn off my temporary axes. Turn off my temporary axes. And now I'm going to jump to this view here. Hide this guy to get it out of the way. You can see that's spot on. That came spot on to that 50 millimeters to get me there. So that's one way to do it. So I added a plane, I added draft. It's one way to do it. Let's go ahead and suppress those and show you another way to do it. suppress those two. So that's one way to do it. I could have come in here and say on the top plane, draw a sketch, and I'm going to draw a line that comes from here to here. Again, I'm going to hide this little helper sketch that I have. And what I want to do is I want this to go through that same point there. So add a point to this line at its midpoint. And I'll make this midpoint here and this line, this edge here, and this midpoint, I'm going to build a midpoint relation. So that captures that so that it's always on that line there. And then last thing we'll do is we'll add a dimension here, and that's going to be 8. So I've done it that way. That's kind of nice. And I'm going to use a surface here and actually extrude that line as a surface. You just bring this up and we'll extrude that line as a surface. And then I have the surface there. So what do I do with it? I use the replace face command. So I'm going to replace this face, right click, with this face. What it's doing is it's actually reusing one face, or it's taking that face and replacing it with the surface I just created. So if we hide this, I can hide this just by hitting the tab key. Again, I get exactly the same thing I want. So that's kind of a cool way to do it. I had to create a surface and I had to create a replace face. So let's go ahead and suppress that. It's just another way to do it. Another way to do it, which I think is pretty cool, is to use the move face command. So what I'm going to do is you have the option to offset, rotate, translate or rotate. I'm going to rotate this face. Now, I could define the axis. That means I have to come in here and get a vertical axis that I want to rotate that about. I don't have that axis. I don't feel like coming back for it. But I know the distance of this hole back to my face back there is 22 millimeters. Right now it's positioned it at 18.5. So let's just type 22. Puts it right at the center of that hole. And I want to rotate about the y-axis here. I'm looking at my triad here. I want to rotate. I can do this. I can do this. There's my y. There's my triad there. I want to rotate 8 degrees. I get a nice preview what that's going to look like. So I'm just using the move face command to rotate that out a little bit. So that's kind of another just a third way to do it. That's a single feature. If you're trying to be really efficient with your features, that's one way to approach things. Counterbores, we already did that. We already did our fillets. We didn't do anything. Our fillets just ran automatically for us. So that's it for that particular one. And we'll do a little simulation on this one too. So we'll go to our Evaluate tab, Show Simulation Express, come in here and hit Next. I like to use this side over here when I'm in here. So I just right click and I can say I want to add some fixed geometry. I'm going to fix this face. And actually I'll come, we won't do that yet. I'm going to add my force. I'm going to add a force onto this face and onto this face. And I'm looking at my sheet here. I didn't refer back to that, but that's what it's telling me to do. Add a 1,000 Newton in a direction that is this way. 1,000 Newtons, and that's per item. So my total is going to be a total of 2,000. So be careful when you're doing this. Make sure you're applying it either at the total force or per item. So that those are the items that are selected there. So we'll go ahead and accept that one. And we'll turn off our little simulation symbols. So we've done everything. I got our material. All we need to do is jump ahead to run. I can hit the run button. All right, does the part deform as you expect? Yes, it does. And then factor of safety again around 4 this time. So we'll just key in a value of 6 to show the colors of everything underneath there. Again, you have access to all the different plots that you may want to see for this particular model. You can animate these. That's kind of fun stuff too. So let's see, we're getting close on time. I think my friends that are on here are doing a great job answering questions for me. Yeah, some of these things, some of these model Mania parts are actually reused inside of the certification exam. So these are things that are very important for certification. In reality, this is just a friendly contest that we try to provide for our customers and for our resellers to compete against each other, and maybe learn a couple new things here and there along the way, and really just help you with everyday design work as you go. So now before I end, and we could go on and do another one. I think Olga will probably kill me if I open up another one, do another 30 minutes. But let's talk about where we can find more information about these parts and about Model Mania. So I'm going to just bring up a web browser here. Close that. And I'm going to go to my SolidWorks. I got to put this on the screen so you can see what I'm doing. So go to my SolidWorks. Go to mysolidworks.com. You can log in. You don't need to log in. This is all free. Most of the stuff is free. Some of the advanced training stuff is there. So you just do a search, Model Mania, and I'm not going to put anything but that. And I'm going to tick this blogs thing here, because if you tick that blogs thing, the first one that'll pop up over here is 21 years of Model Mania. So these are the Model Mania parts that we've done since the year 2000. You can see what they look like over the years. These are the last two ones that we just did. But the cool thing about it, if I scroll down here, what you can do is you can go get the drawings. If I click that drawing, you can print this out. You can test yourself as well. We did not provide the actual models because we want you to do it. So you can do the phase 1, do the phase 2, close that, and then you can watch a solution video of how it might be done here. So that's actually, this is actually 3D Experience World this year, where we actually gave out the prizes and the winners that came up to win. But you can see I go through it here. You can see it's also only 8 minutes. So this goes through in a very fast, quick and dirty fashion, because it's mainly just to highlight what Model Mania is. What we do here in this session, and we've done in some of the webinars, is actually spread it out. Actually, if you go back to some of these earlier ones from 2014 and earlier, Jeremy Ragnaros did a whole series all the way up to 2014, where he actually steps through in a slow fashion, very similar to what we did here on this live session here. So everything 2014 before, go check out what Jeremy did, because he did a really killer job of walking through, showing different techniques, which ones are better than others. And like I said, part of it is just here. There's 3 ways to put that draft on that face. Every one of them is valid. Every one of those solutions is valid. You get to choose which one might work for you, but I think it's important that you understand that these techniques and methodologies are available, so that when you stumble across something that's a challenge down the road, you can do it. Remember, we did that face fillet. There were very few people, when I graded all the parts, that actually used a face fillet to do that. Actually, what I do want to show you, which was kind of cool, is some of the various. This was the Model Mania 2020 part. So this was one of our directors. So normally when I put these parts together, I send them out internally to some of our experts, and some of our experts, and some of the people that want me to send it to them, and they want the challenge of clicking through this and figuring it out, are Mark Martel, that did this one here. He's one of our directors. Paul Adams is basically a VP of sales, and he always wants me to send it to him. He always sends me a part back. So it's interesting to see the high level of people that work at SolidWorks and their interest in still doing the nut and bolt part design. They just love it. So anyway, the one, I'll go through a couple examples here. Mark Martel, he gets the prize for doing it in the least amount of features. So he did in 5 features. Somehow he was able to get through it in 5 features. But if you look at his sketch here, he even admitted this was a little difficult to put all this information into one sketch. He did use a sketch pattern to pattern things around, and that helped. But you're trying to lay out a sketch like this, and I will say that, if you wanted to change that to 4, these 30s they don't really behave very well. So he was able to get through it, but that's one example of what he did here. Let's look at some of the other folks who did some things. Oh, this one, guy I mentioned before, Jeremy Ragnaros, very innovative way of putting that hole in there. He used the advanced hole feature. Never would have thought of it, but just brilliant, just brilliant. So the cool thing about the advanced hole feature, it allows you to choose a near side face and a far side face, and then define. What he did is he defined his counterbore to be offset from face, that bottom face of 4, and then for the clearance hole, it just went up to the next element. So he maintains that design intent. If this thing grew in height, he'd still have all that design intent there. So that was brilliant. If you haven't played around with advanced hole, might not be the thing to try out in a Model Mania contest unless you're quite familiar with that particular feature. So that's kind of cool there. There was one other one the one that Toby did. Let's look at his. Toby, approached it different. Like I said, everybody approaches it a little bit different. He kind of created a layout sketch to kind of get himself organized in position, created one big revolved, and then did cuts like this, patterned the cuts around. So again, they're all different, all valid ways of performing it. The good thing about Toby's is he didn't really have much trouble with these fillets. So it depends on how you approach it. He didn't have to worry about face fillets or any of that type of stuff. It was just part of his sketch. Same way with the other one that Mark Martel did, where he had only 5 features. He didn't have to worry about that because it was all part of the sketch. So it depends on how you approach it. I think they're all valid ways of doing things. So we're at our time of 2 o'clock. So yeah, crazy fast. I'm sorry. This is. It's part of the contest is it does go fast. This isn't a slow training session by any means, but it's really for probably intermediate to advanced type of users to pick up a little extra tip or technique that they might not have known along the way, improve their SolidWorks skills, make them more productive. So I apologize for it being so fast, but that's part of the competition too. Got some folks from Germany. Marvin, good to see you. Hi, Amy. Good to see you as well. So we do have more SolidWorks lives coming up. This SolidWorks live designs coming up on Monday. Michael Steves is going to show you how to do some cool home projects and build a height gauge that he built for his kids, so he can keep track of their height as they grow. So that's kind of cool. I can't remember on next Fridays is. I know Jeremy's got one coming up. Peterson's got one coming up. Every Monday, every Friday, 1 o'clock Eastern time. Tune in and catch that. So from here in Cincinnati, thanks for everyone for tuning in, and so long.